Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. Our names are Janya and
Arya,
and we are your hosts for episode number 5 called the Chemistry of Antacids, which is also what we will be discussing today. But wait up 1 second. What medicine do ants take when they eat too much chocolate?
I don't know. Ants don't eat chocolate.
It's antacid, get it? Antacid?
Oh, yes, I got it. Ants, and then acid. Oh, yeah.
Exactly. So moving on from that, for this segment we're going to be talking about what antacids are and in what situations they can be used for. So do you know what antacids are?
Antacids? No, not really.
Well, they're medicines used to treat heartburn and indigestion.
But what is heartburn? Is it like my heart's burning and it's like on fire?
No, heartburn is caused by excess stomach acid that travels up the esophagus, which is your food pipe.
Ew, that sounds gross.
Yeah. So if you want to reduce them, you can reduce the amount of acid that's in your stomach by eating less acidic foods such as tomatoes, oranges, and chocolate. Yes, if you want to have less heartburns, then it's probably a good idea to eat less chocolate.
Okay, right. So when you eat less of these foods, the acid won't have a chance to travel up the esophagus. I get it now. But I don't really want to limit my the amount of chocolate I eat.
Well, if you don't want heartburns, then it's probably a good idea to limit it. But anyways, antacids also take on this similar role because it reduces the amount of acid that's in your stomach. Well, technically the excess acid. And then your problem is solved. But not really, because it doesn't treat the actual cause of heartburns or indigestion. It only treats the symptoms, such as a burning sensation or pain in your chest or stomach, an acidic taste in your mouth, or the feeling of being bloated. And antacids not only treat these simple problems, but also more serious problems, such as acid reflux, stomach lining inflammation, known as gastritis, as well as stomach ulcers.
Oh yeah, when I was watching the TV with my grandpa, I saw a bunch of ads on TV about acid reflux and how antacids treat that. That's so cool.
Exactly. It's really fascinating to see how this works, which we'll get onto later. But some common active ingredients in antacids include aluminum, calcium, magnesium, and salts such as sodium.
And these active ingredients help raise the pH level in the stomach, reducing the acidity and providing temporary relief from the symptoms. Antacids usually provide quick but short-term relief, and they're definitely not intended for long-term use. It's also important to just read the instructions that are provided on the bottle, that's also provided by the manufacturer, or consult a healthcare professional for appropriate usage and dosage recommendations.
Exactly. So on that note, we'll get into the chemistry behind antacids.
Ew. Chemistry. That's probably what all of you guys are thinking. But chemistry is very important to create the antacid, so it's definitely important to know how these things work.
Exactly, especially because it helps your body so much for some people in everyday life. So one chemistry idea behind antacids are acid-base reactions, which has to do with active ingredients. So there are many ways to define acids and bases in these type of reactions, but one of them is called the Bronsted-Lowry theory. And this is differentiated from other theories because it involves the transfer of a proton. So in this, the acid and base react together to form a conjugate base and acid. And this remains in the stomach to neutralize the excess acid. So the Bronsted-Lowry acid donates a proton, and the Bronsted-Lowry base accepts the proton. So the conjugate base will also accept a proton and neutralize the acid. So this is how antacids work. And oftentimes, these reactions produce a gas such as carbon dioxide as well as water. And now taking a specific look at antacids, a weak base is used to neutralize the acid that's in your stomach by stopping the enzyme, which creates acid for the breakdown of food for digestion, and this is known as pepsin. So I know this can be a lot to take in, but basically the enzyme called pepsin produces more acid so that food can be digested. So antacids reduce this enzyme, pepsin, so that excess stomach acid isn't there. So antacids usually contain various active ingredients such as aluminum hydroxide, magnesium hydroxide, calcium carbonate, or sodium bicarbonate. And almost all antacids act on this excess stomach acid by neutralizing it with these weak bases. Now you might ask, why aren't strong bases used? Well, it's because it disrupts the pH of important organs in the body, and this could lead to the damage of these organs. Now we'll take a look at reaction between calcium carbonate, which is an active ingredient in Tums, a common antacid, as well as hydrochloric acid. So when these two items, when these two react together, it produces carbonic acid and calcium chloride. So these are the two things which help to neutralize the excess stomach acid. And the active ingredients that were mentioned help to maintain the pH stability of the stomach. They help to raise the pH level in the stomach by reducing the acidity and providing relief from the symptoms.
Okay, so the pH scale and buffer is very related to the acid-base reactions, but the pH scale is also a little different at the same time. The pH scale determines how acidic or basic water is. The range is 0 to 14, with 7 representing neutrality, and acidity is indicated by a pH value below 7, whereas a base is shown in a pH value of 7. In reality, pH is just a measurement of the amount of hydrogen and hydroxyl ions in the water. And you also probably know that pH is very important when it comes to regulating the pH in a pool, and that's another place where we've definitely seen pH be present. But moving on, a buffer is a substance that can withstand pH shift when acidic or basic substances are added. Small additions of acid or base can be neutralized by the buffer, keeping the pH of the solution largely constant. A buffer is very important and is very directly related to the antacids. And in our case, the buffer's job in the body is to keep both intracellular and extracellular pH levels within a relatively small range and to resist against pH variations brought on by both internal and external factors. The buffer that is created in your stomach after taking an antacid table keeps the pH in your stomach acid from changing too much. The buffer in the antacid is usually composed of 2 particles, and those 2 particles are bicarbonate and carbonate. And going back to how these antacids contain the buffer, the antacids that contain the buffer that maintains the pH of the stomach. Most antacids have a net pH of above 7 for the sole purpose of maintaining the pH stability in the stomach. So basically, like what I said before, the buffer is what keeps the pH stable in your stomach. And that's pretty much what we're doing in the pool as well. We're trying to keep the pH the same by adding different chlorine levels.
Yes, exactly. So now we're done with the chemistry, and we'll move on to personal connections.
So by this, you probably have a little hint that both of us are very interested in science, and we also have a very keen interest in medicine. And this topic interests us since we've had personal experience with using antacids, whether it was us, whether it was a family friend, or whether it was a relative. We've used it for indigestion and heartburns in the past, and it has worked fairly well. and another indirect use of it has been to treat mouth ulcers.
Yes, so I've had personal experience with this because I often get mouth ulcers, and a common remedy that I use is actually antacid because I dab some of it on the mouth ulcer where there's excess acid, obviously, and surprisingly, it worked almost immediately. The pain significantly reduced, and the swelling also reduced over time. And some of you might not know this, but the base that's in the antacid leaves a chalky feeling in your mouth.
Ew. And was it like a weird consistency too?
Well, no, it was like liquid, but the feeling of like the chalkiness in your mouth felt weird. So watch out for that if you're going to have an antacid anytime soon. But yeah, it significantly helped with reducing the symptoms, and in general, it's important because many people experience indigestion, heartburn, and ulcer every day. So it's good that this medicine was developed to treat a very common problem.
Thank you for listening to this episode of Chemistry Connections. For more student-run podcasts and digital content, make sure you visit www.hvspn.com.